Next, I want us to find the distance between the two ships on the map. And I want to estimate the ship's location to the nearest whole number coordinates. After that, we're going to find the midpoint between these two ships on the map. So it would be a good idea first to figure out where these ships are. So I'm going to estimate it to the closest whole number coordinates. So this is where x is 3 and y is 2. And this ship at where x is 5 and y is 3. So we're going to need the distance and the midpoint formulas, which you will be given, right? So let's do distance first. Distance is the square root of x1 minus x2 squared plus y1 minus y2 squared. And it doesn't matter which points x1, y1, and which points x2, y2. You'll get the same answer regardless. Isn't that nice? So let's let this be x1, y1, and this point here be x2, y2. I get the distance is the square root of 3 minus 5 squared plus 2 minus 3 squared. So I'm going to get the square root of 3 minus 5, which is negative 2 squared, plus negative 1 squared. So I get the distance is the square root of 4 plus 1. So the distance between these two ships, the length of this line segment right here, is the square root of 5. And you can leave it like that, or you can plug it into your calculator and get an irrational number. I mean, this is an irrational, number. Okay. Next I want to find out the midpoint. Let me switch colors. How about that? So the midpoint's like right in the middle, right here. So I want to calculate the midpoint. And I'm writing out all of midpoint because I don't just want to use the letter M, because M can also be used to represent slope, and I don't want us to get confused. So I'm going to take x1 plus x2 divided by 2. That makes sense. You take your x's, add them, divide it in the middle. Here we are in the middle. And then y1 plus y2 divided by 2. So that gives me a midpoint of 3 plus 5 divided by 2, comma 2 plus 3 divided by 2. And I find that my midpoint is 8 over 2, comma 5 over 2. So that gives me 4, comma 2.5. And I was really close. I guess it's right here. Right? Here's our midpoint. 4, comma 2.5. This is the midpoint. All right, next I want us to graph 4 over x minus 2. I want us to find the asymptotes and state the domain and range. So remember, the first thing we need to do is set our denominator equal to 0, because this tells us what points we're going to leave out of our domain. So my domain doesn't include the value when x equals 2. That is our vertical asymptote. So our domain is all x values except x equals 2. So I'm going to go ahead and draw a little dotted line at x equals 2. I know my graph is not going to cross right here. Now, I need to determine if there's a horizontal asymptote. So we're going to look at our horizontal asymptote rules that were given. We just need to know how to use them. So the first horizontal asymptote rule states that if the degree of the numerator is less than the degree of the denominator, there's a horizontal asymptote at y equals 0. Well, the degree of our numerator is 0, and the degree of our denominator is 1. So because 0 is less than 1, we have a horizontal asymptote at y equals 0. Okay, so these are the lines our graph is not going to cross. I need to find some values. So I'm going to want to pick some values on both sides of my vertical asymptote. I'm going to take a look at when x is negative 1, 0, and 1, and when x is 3, 4, and 5. So if x is -1, I have 4 over -1 minus 2, so that gives me -4/3. If x is 0, I have 4 over -2, so x is -2. And if x is 1, I have 4 over 1 minus 2, which gives me 4 over -1, which is just going to be -4. So let's go ahead and graph this side. I have when x is -1, y is 4/3. I'm going to guess that's right. -4/3. I'm going to guess that's right about here. We know it's a little more than 1. When x is 0, y is -2. And when x is -1, y is -4. So here's my graph. Woo. And it never crosses our asymptotes. Next, I'm going to look at when x is 3. I have 4 over 3 minus 2. That's 4 over 1, which is 4. I have 4 over 4 minus 2. That's 4 divided by 2, which is 2. Remember, there's some symmetry here, kind of. And then I have 4 over 5 minus 2, which is 4/3. So I have when x is 3, y is 4. When x is 4, y is 2. And when x is 5, y is 4/3. So my graph is going to look like this. Now I just want to double check to make sure I've answered this correction properly. It says to graph my equation, which I've done. I found my asymptotes. I stated what they were. I stated my domain, and I stated my range. So I have fully answered this question. I didn't want to miss anything. Next, let's look at f of x equals x squared times x squared minus 16. So I need to know what the zeros are. So the first thing I'm going to want to do is set this equal to 0 once I make sure I've gotten it fully factored. Okay? So I have x squared, that's fully factored, cool. Well, I could write that as x times x. Then I have x squared minus 16. That's a difference of perfect squares. So this is going to factor to x minus 4, x plus 4. And if you weren't quite sure how to get that, you should go back and look over how to factor. So I set each of these equal to 0, and that's going to give me my zeros. That means I have x equals 0. So I have 0 is 0 with a multiplicity of 2, meaning it occurs twice. I have x equals 4 is a 0, and x equals -4 is a 0. So what are these? These are the x-intercepts. The x-intercepts are when y is 0, because that's when we have an x-intercept, x is 0. When y is 0, x is -4. And when y is 4, x is 4 when y is 0. Now what's the y-intercept? Well, the y-intercept is when right here, right? We already stated it. Because that's when x equals 0. That's when we're going to cross the y-axis. And you could see this from our graph that we're about to sketch out. And I just want you to make a rough sketch. Feel free to use your graphing calculator. Okay? But let's go ahead and plot our y-intercepts. So I had 0, 0, 0, -4, and 0, 4. Okay? And I'm going to see if I find a few points, which we're happy to do, right? I could check what happens when x is 1, and when x is -1, and when x is 5 and -5, right? These would be some good points to see what's going on with our graph. Just substituting in. So I'm going to have x is 1. 1 squared times 1 squared minus 16. That's going to be 1 times -15, so just -15. So my graph is like all the way down here already, right? Then when x is -1, I have, let me erase that. This was when x was 1. My graph is already down here, like pretty far, okay? And then I have that we're going to be symmetrical. So I've got The same thing going when x is -1, right? Because it's squares. I'm still going to get -15, so I'm over here. So let's change our scale. Let's make this a scale of 5, 10, 15. So my graph is down here. Next, let's take a look at 5. So I've got 5 squared times 5 squared minus 16. So that gives me 25 times 25 minus 16. 25 minus 16 is 9. 9 times 25 is 425. Wow, that's a big number. So now we're like all the way up here. And I know I'm going to have symmetry because we square it. So my graph looks something like this. And that's all I want. I want a rough sketch of what our graph looks like. So this is the final question on the final exam review. Remember, if you have any questions, to reach out to me. I'm happy to have a Zoom meeting. I'm happy to make up some more examples. Remember, I'm here to help even though we aren't in class together. My thoughts are with you guys. So good luck as you study, and I can't wait to see how much you've learned over the course of this semester.